Welcome back, everyone. This is your second video for the Sensation and Perception module. This time I'm going to be going over concepts regarding the system of sensation and perception of touch. The skin, the largest organ in the body, is the sensory organ for touch. The skin contains a variety of nerve endings, combinations of which respond to particular types of pressures and temperatures. When you touch different parts of the body, you will find that some areas are more ticklish, whereas other areas respond more to pain, cold, or heat. The thousands of nerve endings in the skin respond to four basic sensations: pressure, hot, cold, and pain. But only the sensation of pressure has its own specialized receptors. Other sensations are created by a combination of the other four. For example, the experience of a tickle is caused by the stimulation of neighboring pressure receptors. The experience of heat is caused by the stimulation of hot and cold receptors. The experience of itching is caused by repeated stimulation of pain receptors. The experience of wetness is caused by repeated stimulation of cold and pressure receptors. To explain why thoughts and emotions influence pain perception, Ronald Melzack and Patrick Wall proposed the gate control theory of pain. This theory postulates that a gating mechanism exists within the dorsal horn of the spinal cord. Small nerve fibers which contain pain receptors and large nerve fibers which contain normal receptors synapse on projection cells, here labeled with a P. These fibers then go up to the spinothalamic tract to the brain, and inhibitory neurons, here labeled with an I, within the dorsal horn of the spinal cord. The interplay among these connections determines when painful stimuli go to the brain. In this first situation, when no input comes in, the inhibitory neuron prevents the projection neuron from sending signals to the brain. The gate is closed. In this situation, normal somatosensory input happens when there is more or only large fiber stimulation. Both the inhibitory neuron and the projection neuron are stimulated, but the inhibitory neuron prevents the projection neuron from sending signals to the brain. The gate is closed again. In our third situation, we have pain reception, also known as nociception. This happens when there is more small fiber stimulation or only small fiber stimulation. This inactivates the inhibitory neuron, and the projection neuron sends signals to the brain, informing it of pain. So in this case, the gate is open. Descending pathways from the brain then close the gate by inhibiting the projector neurons and diminishing pain perception. So according to the gate control theory, it would make sense that if you were experiencing pain, you could counteract that pain by stimulating more of your large fibers. So if you hit your knee and you started rubbing your knee by providing pressure and other stimulation that is not painful, you could diminish your experience of pain. In this video, we went over different ways our bodies experience touch. The sensation of pain, pressure, cold, and heat all arise from specific patterns of receptor stimulation. Further, we have the gate control theory of pain perception. Our body has the ability to adapt to pain and gate the perception of pain by turning off the pathway received from small fibers which contain pain receptors. I hope that you enjoyed the video, learned a lot, and are getting well prepared for your discussion tomorrow as well as your quiz on Thursday.